x-intercept. Now these are important points. Now the other important point on a parabola is going to be the vertex, right? Remember this is a sideways vertex. Now, on a regular one, it's, don't write this down, x equals negative b over 2a. So on a sideways one, it's actually, instead of x, it's going to be y for the vertex. Now, where's the function? Here. When I say function, it's not technically not a function. Looking here. A in this case is 1/2. What's B in this case? It's 0, right? That would be the 0y portion of it. It would be this. Right? That's your B. So in this case, this gives me 0. And we already know when y equals 0 what we're getting. Y equals 0 is here. So this is also a vertex, as well as the x-intercept. So we have a lot of information so far. By the way, what is root 6 about? Well, we'll need sort of a decimal approximation there for our graph. 2.44, somewhere in that range. So almost 2.5. And negative 2.5. Next up, I need to know the point of intersection between these two functions. So I could do x equals y plus 1, and plug it in there. And then solve for y squared. I'm going to multiply through by 2. And move everything over, so we get y squared minus 2y minus 8, 0. Gotta love textbook problems. Nice, pretty. You're into it. So these are my points of intersection. Make sure your neighbor understands where I got these other values from, these x values. It's like magic.
You just plug them in and solve them for x. Yeah.
So where did I get my x values from? You plug it in. Now I can plug it into either here, or I can plug it into here. For sure, I plug it into here. Okay? But either way, both the points should be on both graphs. I think we have enough information now that we can actually piece this together. I only need 2 points on the line to graph a line, right? So I already have 2 of those points. Otherwise, I could do slope-intercept form. See if we can figure this out. All right, the x-intercept is at negative 3, which we also know is the vertex. All right, next up we have the y-intercepts. Y-intercepts in this case are at, you said it was 2.44? About? Sounds about right. So about, yeah. And about yeah. We also have the points of intersection, which is 1, 2, 3, 4, 5, 1, 2, 3, 4, and negative 1, negative 2. And we can actually see the parabola at this point. And if you were to use your little calculator things, it would look exactly the same. Not exactly, more exact, of course. So what area are we referring to in this case? This area here, right? That's the area of interest. Let's make it pink. Yeah, I got pink in my shirt today. Wife bought it for me.
Aw.
That's what I was going for, keep. Now, notice that everything is in terms of y in this case, so dy is going to be clutch. Now, this changes everything. We are no longer looking up and down. We're now looking sideways. And when I look sideways, where x is positive in this direction, which one is on top?
The line.
Of course, all you have to do is turn your paper, right? You can do that. So the line's on top, right?
Right.
In this case, meaning which one's further positive? In the x direction. That's going to be the line. So, we'll go to here. So the area of interest is going to be the integral, and the y values are going to be from here to here, which are from -2 to 4, or -2 to 4. The y values now, of the line, which is y plus 1, minus the parabola, which is down at the end there, minus 3. At this point, I don't care what the answer is. I want to make sure you understand how to do the setup. So start from the beginning with someone. Walk them all the way through till you hit the integral. One step at a time. I want everybody talking. I'll throw things.
Okay. What was the first thing he did?
He
Got his intercepts.
for the parabola.
Where they intersect, like for just for the parabola.
Yep. First thing he did.
Okay.
Then he found the vertex for the parabola.
Okay.
Then he equaled the line to the parabola to find the the intersects.
Where the line and the parabola intersect,
Yeah.
right?
Then he found which function was positive to decide where they would go in integral.
So, do you think that because we know that there's a parabola, that's the best one to start with?
Yeah, probably.
Who's got the most points?
Yeah.
And a line's got to intersect it somewhere, so you want to figure out where the parabola is.
It's the most work.
So once you have all that information, you saw the vertex. Explain to me how he brings the line into the equation. He's got x equals y plus 1 because he moved it around.
Yeah. You know how the x equaled the parabola thing, right? X equals 1/2 y squared minus 3, that thing. And so, the line.
He used that as a value for
He
x.
switched the x so he could get the y
Okay.
into the function, and then he just put it into x.
And then he set it to 0. Right?
Yeah.
After you and your neighbor are convinced on how to get